Good afternoon, everyone. As she said, my name is Lauren Velker, and I'm the GIS coordinator for St. Louis County ECC. St. Louis County is currently in the process of deploying Next Generation 911. And we plan to start processing calls on the Next Gen 911 system in the fall of 2017. And if you don't know what Next Gen 911 is, it's an IP end-to-end system that will replace Enhanced 911. And we'll take care of call taking, call handling, dispatching for 911 services and public safety services. As some of you may know, GIS will drive Next Gen 911's critical call routing functions, so the need for accurate and precise GIS data is really more important than ever. But how do you facilitate that transition to support Next Gen, and how do you get your information into the Next Gen data model? So today I'd just like to give you a look into the transition process at St. Louis County's geodatabase model into NENA's Next Gen 9-1-1 geodatabase model. St. Louis County, Missouri is located in the eastern portion of the state. It's approximately 523 square miles, has 90 municipalities, and is home to about 1 million people. So it's a pretty large area, very densely populated, with a lot of people to provide emergency services to. We have 56 police departments, and many of these 56 PDs actually contract their municipal locals that will contract with St. Louis County for various services, including patrol, dispatching, even records management services. It just kind of depends what they're looking for. St. Louis County does have 8 precincts. We have 23 fire districts and 20 municipal fire departments, 34 EMS providers, and 20 PSAPs, or public safety answering points, where we take 911 calls. In 2016, St. Louis County PSAPs processed approximately 900,000 calls for service to 911. So this just kind of gives you a snapshot of how busy we are. On the county government side, the St. Louis County GIS Service Center provides data and services for many county governments, county departments, as well as the public. And if you were in here for the last talk, you probably heard Trent talk about Michael Baer and how to implement using Windows Task Scheduler if you don't have really the means to go for an FME server or FME cloud. So it just kind of, we've really embraced FME at St. Louis County, and it's completely changed the way that we think about GIS and the way that we work with GIS on a day-to-day basis. And we've been able to incorporate some of that into the public safety side of it as well. But St. Louis counties and their GIS, our whole vision is to move away from this idea of data silos, and we really want to manage our GIS data in a central cohesive GIS that can support many different functions, not only for county purposes, but for the public as well. We use a production database where data creation and maintenance takes place, and then we replicate to our data warehouse where data can be consumed. We've embraced ArcGIS Online and open data, so our data is out there and available for the public to use whenever they like. We really strive to give back to the county and to the community by making the data and the applications available so that everybody can, use it and visualize it for their purposes. From a public safety standpoint, the GIS Service Center and myself over in the police department, we've really focused our address points and our street centerline information to directly support 911 function within the county. We've really focused on our data stewardship. This includes laborious QA/QC processes and even incorporating field work to make sure that our data sets are as accurate and precise as we can make them. We've updated our schema and fields to bring it into compliance with the CLDXF, which is NENA's standard for defining core data elements for the exchange of civic data information, which will go into in Next Gen 911. And this process for us, we were pretty close anyway, but it just pretty much involved making sure that all of our street name elements and address elements were all parsed into separate fields, and that all the information was entered correctly into those fields as well. No special characters, things like that. This slide will just show the high-level workflow of the transition to the Next Gen 911 staging database. From production, we replicate to our in-house staging database, and it's there that we translate from staging to the Next-Gen 9-1-1 schema. We didn't want to replicate directly from our production for obvious reasons. We upload to the vendor for their QA/QC process, and after they pass their QA/QC, we can provision to our redundant data centers A and B, which are housed in the EZNet, so for call processing and handling. So the approach is really research from the get-go. For the Next-Gen 9-1-1 deployment, I incorporated lessons learned and best practices from implementing Esri's local government information model, and I used that methodology to translate and build the model for the Next-Gen 9-1-1. The rest of my presentation is going to kind of focus on those best practices as they relate to Next-Gen 9-1-1. But first, you absolutely must familiarize yourself with the data model. For the LGIM, this included things like the getting started, helps, webinars, forums, things like that. For the NINA GIS data model, you're really looking at the documentation that's currently out for review. It's meant to support not only the Next-Gen 9-1-1 systems, but also databases, call routing, and call handling. The documentation is really overcomplicated at times because they're trying to make a one-size-fits-all model for everybody, and as we all know, one size does not fit all. So it's really important to focus on, what's important for your in-house internal work. So then I came to the realization, I am a geographer, and what geographers do? We build maps. So that's what I did. This map that in this process is commonly referred to as a crosswalk table. I used Excel to build a side-by-side comparison between our data model and the Next-Gen 9-1-1 data model. The NINA documentation is really your data dictionary for this process, and so while it's overcomplicated, you really need to focus on, the required layers, strongly recommended, and then you can kind of build out from there. What I did was I listed all of our Next-Gen 9-1-1 fields and data requirements, and then next to them I kind of added another column where I could satisfy those field requirements with data that I currently maintained. The feature class comparison really allowed me to see both data models side by side, feature class by feature class, and field by field. So I could see what the county had data to support and what we didn't. On the screen, you can see how this comparison is used using the different colors to satisfy the requirements. And then once I had everything organized, I was ready to start working with the Next-Gen 9-1-1 schema and database model. So in Esri, I used X-Ray for our catalog to create a blank file geodatabase with just some feature classes that represented Next-Gen 9-1-1 layers. Then you use X-Ray, and I actually exported that almost blank XML document. And using X-Ray, you can actually edit that XML directly in Excel. And this involved anything surgical that I had to do with the database. So adding not feature classes, but adding any fields, any domains, any definitions, field types, lengths. This can all be done in Excel. And you can really just build it out step by step. And the XML will look very similar to the Excel crosswalk table. And by having all of that feature class information there and in one place, you're able to build out the XML schema and satisfy all of the requirements of Next-Gen 9-1-1 right there in Excel. So it made it very easy. And then using X-Ray, you import that saved XML that you worked on in Excel, and you import that back into an empty file geodatabase, and voila, you have your Next-Gen 9-1-1 data schema. So once the data is the way that you want it, the schema is the way you want it, you get to go play with our wonderful software, FME. So when I first started looking at the LGIM data model, I didn't know what FME was. I had never been introduced to it before. So I approached FME the way I approach most things. Like I researched the hell out of it, right? Like I just beat it to death. Free training, webinars, FMEpedia, FME Evangelist was wonderful for trying to figure out the basis of how to do some of these translations. And while these resources are really excellent and they really offer you some great insight, it's really easy to lose focus and kind of fall down a rabbit hole because you start doing some really neat things. So keep reminding yourself to focus on the prize, think about what it is that you're actually trying to do. I think working the problem and building the translation piece by piece really allows you to become confident using FME. You can look at the tutorials and examples at first, take a step back, and then think about what you want to accomplish within your own department and start working from there. I always recommend building a translation from scratch because you get a clean slate to work with. You're not bound by a template or any parameters that might be nuanced or, not necessarily apparent to a beginner user. And I also found that my translations were generally a lot happier when I built them from scratch as opposed to using a template, and some prefab parameter that I was trying to plug in some information into. And I skipped a slide, so I apologize. But this is a snapshot of the initial workspace in the translation to NG9-1-1. The initial model includes address points, street center lines, and emergent service boundary layers, and that's my fire, law, EMS, and PSAP. It's much simpler than my LGIM translation, and just for nostalgia, I wanted to give you guys a snapshot of that. It included 43 feature classes and was a bear to begin with, but a labor of love. So the transformers become pretty repetitive throughout the entire model, both from the LGIM and in the NG9-1-1 data model. And I'll go through a couple of these in a little bit more detail on subsequent slides, but just a couple to touch on. Attribute creator. If you know that you have a field that needs a specific value for an attribute, you can write the statement here that will populate that value throughout the entire field. It's also worked really well if you need to concatenate any attributes. I recommend it for that. Testers, you set up if-else statements just to satisfy any requirement you might have. Timestamper and date formatter. Time and date are very, very important in public safety, so you can do that in different formats by using these two transformers. Attribute manager is really kind of a godsend. It's kind of the son of the attribute renamer, and that's primarily what you're using it for here, is renaming your attributes. So you're taking your source field name and you're renaming it to your target. Use your Crosswalk Table as a cheat sheet. That's why it's there. It's a great resource. Just a quick example, ADR-NO in St. Louis County, what's our address number field, becomes address_number in the NG9-1-1 data model. They like everything spelled out, so that's why we do that. So we kind of do that across the board. Also in the attribute manager, I was able to set some of the default values rather than having to use an attribute creator later in my translation for some of the other things, but it just kind of depends on your requirement and where you need that populated and where it's created and things like that. Schema Mapper and Attribute Value Mapper. I use these transformers to do any source target mapping of any domains and coded values that needed to be set in the target database. Basically, I built these out in a CSV file. These are my municipalities, my street directions, and all of my street suffixes that have to be in accordance and compliance with the CLDXF that I mentioned a little earlier. And I definitely recommend the Schema Mapper for any of your larger domains. It makes it, and FME Evangelist has a wonderful blog series on the Schema Mapper, so if you haven't, check it out. I definitely recommend it. Helped me through some dark days. I use the Attribute Value Mapper to set any domains with less than 5 coded values. And all you're saying is that if the code and the source attribute value equals this, you want it to equal that on the output side of that translation. In the NG9-1-1 data model, emergency services boundary layers are required to be separate layers instead of one boundary layer. Right now, we maintain this as an ESN, emergency service number. It's also known as ESZ, so emergency service zone layer. And it's basically designates the English language translation for where a 911 call will be routed based on that call location. So it tells me my PSAP, it tells me who I'm going to send for fire law and EMS. Pops up right on my call taker or dispatcher screen, so there's no question, there's no back and forth. They see it right there. It's the most important thing that they want to see at first. But in NextGen, these have to be separate layers. So St. Louis County maintains a PSAP layer and a fire district layer already separately. So all I needed to create was my EMS and police service area boundaries. I used deaggregator, dissolver, and aggregator to perform this operation. I also added a sliver remover in there because some of the tolerance between our layers is pretty tight. So we wanted to make sure it was kind of throwing out some slivers. So we wanted to make sure that all of those were cleared out of there and we weren't having any little extra features that we needed. So since we maintain that PSEP and that fire district boundary layer separately, we didn't include them in this, but obviously you could. It follows the same thing. So basically I'm taking my ESN layer and I'm breaking it down to create multiple singular layers based on attributes. So just to give you what it looks in a geographic output, on the left you have your ESN boundary. We have 159 features. And this was dissolved into 2 layers, my police and my EMS. Police has 57 and EMS will have 36 features. And the reason that these numbers don't line up with the numbers that I read you at the beginning of the presentation is because some of these can't all be multi-part features as we'd like them, because a couple of them are secondary PSAPs. There's a couple other little parameters and things, so they have to be separate features. So after careful formatting of my transformers, I was able to build a translation to load the data from St. Louis County source database into my Next-Gen 9-1-1 GIS Data Model target schema. Data can now be transferred to our vendor, QA/QC'd per their protocol, and provisioned to the EZNet. This is a task scheduled to run in the wee hours of the morning after our production and replication databases have been done. We are St. Louis County. We don't have FME server or FME cloud, so we do use Windows Task Scheduler to run all of our tasks. It has worked very well for us and continues to do so. It is a dream of ours, but we're just not there yet. The takeaway of this and to focus on the required and strongly recommended information and build everything else that can come later. You know, this method and this model is totally extensible because you build it from the ground up, so you decide what you do and do not have data to satisfy. The model is formatted in a standard way so that if you wanted to share your information with another agency, both of you would be able to understand the format and the schema and ultimately be able to read GIS data across jurisdictions, which, you know, if you're a local government or, you know, you've ever tried to kind of conflate data from different agencies, you'll know that it's not always the easiest task. But as long as we have it in a standardized format, it makes our force guide a whole lot easier to use and read. So and by using this method, we're actually reducing the amount of time that it takes for GIS updates to provision to the ESINet. And by association, we're confident that this will help increase the percentage of callers located because the ECRF and the LVF, which are Next-Gen 9-1-1's call routing functions in the ESINet cloud, are actually being provisioned with the exact same GIS information that we're using to populate our call taking maps, our dispatcher maps, our heads up display for first responders. It's all using the same information, and we're confident that it's being actively maintained in an accurate and precise manner, as well as we can. That's for sure. It's never 100% perfect, but we sure try to be as much as we can. Thank you very much for hanging out and listening to my talk this afternoon. I'll take any questions or comments you might have. If not, I hope everybody has a wonderful evening. Thank you.
So that was an awesome talk. I really appreciate you mentioning the FME Evangelist and some of the tools we have for beginning users. It's definitely one thing we really try to do at Safe Software. Wow, it's hard to say sometimes. I said it a lot today. I think that's part of the problem. Actually, Natalie is our acting manager of the Knowledge Center. She's sitting in the room. She's famous. So if you have any Knowledge Center questions, you can direct them her way or to our FME doctors. Does anyone have any questions for Lauren? Either about Next-Gen 9-1-1 or FME?
Yes, and so what the phone company uses in the MSAG and the alley and what they maintain. They use postal community for a lot of those. We do have a field in our address points for postal community, but our Muni for our address points is going to be more accurate than that. So we've actually transposed to use our Muni name as our MSAG community name. And we're going to flesh out a lot of those disparities. We're going through location database mitigation right now to kind of make sure all of the data with our TNs is where it needs to be with our GIS. So some of those will be fleshed out, but there's not a big deviations. The biggest one we see is telephone or TNs using St. Louis as their Muni when it's actually not. St. Louis County is completely separate from the city of St. Louis. St. Louis is just kind of the general postal code for that. So when it's not, we try to make sure that it has either just St. Louis County or an unincorporated designation for those. Did that answer your question?
Yeah, does not sound easy.
But thankfully, a lot of those you can update in bulk. You don't have to sit there and go through each record. You can, do a select and a bulk attribute update on a lot of those as well. It makes
Natalie,
it
did you
easier.
have a question? If anyone else has one.
I was curious when you were doing the attribute mapping from the folder to the new, whether you used the import functionality on any of the transformers to import values from your lookup tables, or whether it was more manual with that.
I did it manually. I just created the CSV and stored that in the local folder where I was working, and I used that to call in the Schema Mapper. So yeah, I did do it manually.
Yeah,
Right,
sometimes
yeah.
that's necessary. Yeah.
Mm-hmm.
That's one thing I learned about the local government model is it's kind of dense and hard to. It's not hard, but it's just very rigid, and trying to get moving pieces into different little slots neatly is tough.
Absolutely, and that's a big deviation between creating the next Gen 9-1-1 model as opposed to the LGIM, because you are bound by some really strict rules when you're working with LGIM, and that this I kind of built from scratch, from the ground up, using kind of a lot of that same methodology. So it was more flexible. It made it more fun.
What do you mean by rules?
So there's relationships. There's the schema is already there and set. You have to be very careful of when you are using X-ray to do any of that schema manipulation within the LGIM. You need to be very careful about how you manipulate that Excel file, because it can get corrupted very fast, and you'll be back at square one before you know it.
What's the point of the X-ray tool?
So the X-ray tool basically gives me an easy way to edit an XML file in Excel. So by using the X-ray tool allows me to export or open up, it deconstructs an XML, and you can then open it in Excel, do all of your database schema changes in there, save it, re-import it into an empty file geodatabase, and your schema will be updated. So I found that it was a really easy way to build an entire geodatabase from scratch, because I could do it in Excel very fast.
Mm-hmm. Any other questions for Lauren? If not, Lauren, you are the grand prize winner of an FME
you.
swag bag.
Appreciate it.
And yes, a round of
Thank you,
applause,
guys.
Lauren. Awesome talk.